Hello everybody, how are you? This is Mr. Fady Raafat, a math teacher at Nile Egyptian International School. Today we are going to explain one of the most important lessons for the third year of preparatory stage. One of the topics of geometry, which is the cyclic quadrilateral. What the meaning of the cyclic quadrilateral? Let's first read together the definition of the cyclic quadrilateral. Cyclic quadrilateral or the inscribed quadrilateral. Okay, cyclic quadrilateral is the same as inscribed quadrilateral. It is a quadrilateral whose vertices all lie on a single circle. Like this picture down, okay, we have different quadrilaterals and all of them, their vertices lie on the circumference of a single circle, like that, okay? So, this circle that pass through the four vertices of any quadrilateral is called circumscribed circle. Circumscribed circle or circumcircle. Circle or circumscribed circle is the circle that pass through the vertices of a quadrilateral. Okay? So, let's read together this question. Is it a cyclic quadrilateral? Is any quadrilateral can be drawn inside a circle is called a cyclic quadrilateral? Of course not. For the first picture here, yeah, this is a cyclic quadrilateral because the four vertices A and B and C and D, all of the four vertices of the quadrilateral lie on the circumference of the circle. But in the second picture here to the right, it is not a cyclic quadrilateral. Why? Because of only three vertices of the quadrilateral lie on the circumference on the outer frame of the circle, which called the circumference of the circle. But the fourth vertex lie on the center of the circle, which is a point does not lie on the circumference. So this is not a cyclic quadrilateral, but this one, it's okay, it's a cyclic quadrilateral. So not any quadrilateral drawn inside a circle called a cyclic quadrilateral. There is a must that the four vertices lie on the circumference of the circle. Okay. Next, can we draw a circle passing through the vertices of any quadrilateral? Any quadrilateral, can we draw a circumcircle that can pass through its four vertices? Let's try together. Think about rhombus. Okay, who can tell me what is the name of this shape, this quadrilateral? Yeah, it's trapezium or trapezoid. And what about the third one here? Yeah, it's a parallelogram. Okay, so can we draw a circle that pass through a rhombus or a trapezium or a parallelogram? If you try to get your compass and draw a circle, yeah, let's try. We cannot do that because if you tried to draw a circle that pass through the vertices of a rhombus, you will find that the circle will pass through only two vertices out of the four vertices of the rhombus, and it cannot touch the other two vertices. Okay, like that, like that. Also for a trapezium, okay, not any trapezium can be drawn inside a circle, or we cannot find a circle that passes through any trapezium. Some types of trapezium could be, but the other couldn't. What about the parallelogram? It's the same as the case of the rhombus. you can draw a circle that pass only by two vertices of the parallelogram, but the other two vertices will not be on the circumference of the circle. So let's make a fact here that not any quadrilateral can be inscribed in a circle, such as its four vertices lie on the circumference of the circle. Okay, so let's see what are the conditions that must be verified in any quadrilateral to be inscribed in a circle, or to be there a circle passing through its four vertices, and which we call it a cyclic quadrilateral. Look at it here, the properties of the cyclic quadrilateral. There are some properties for the quadrilateral that could be inscribed in a circle. And the first one of them is through the definition of the circle. Who can remember the definition of the circle? Circle, it's a closed curved line, whose points, you know that any line in mathematics formed from a very big number of points. Even at a straight line or curved line, it's formed from an infinite number of points. Okay, so circle is a closed curved line formed from a very big number of points. These points are equidistant at equal distance from a fixed point, which is the center of the circle. So this is the definition of the circle. And through this definition of the circle, we can deduce one of the properties of the cyclic quadrilateral. What is this? When there are 4 points, and these 4 points, like A, B, C, and D, when there are 4 points and these 4 points are at equal distances from a fixed point or a certain point, if you find that point A at a distance from the point O, and this distance equal to the distance between D and O, equal to the distance between C and O, equal to the distance between B and O, if there are 4 points at equal distances or equidistance from a certain point, that means these 4 points lie on one circle. And of course, any 4 points can form a quadrilateral if you join them together. So in this case, we have a cyclic quadrilateral. So the first of the properties of cyclic quadrilateral, when we can say that there is a cyclic quadrilateral, if we find 4 points at equal distance or equidistance from a fixed point, they can form a cyclic quadrilateral. Okay, and now let's go to the next of the properties of the cyclic quadrilateral. You notice here a circle, and there is a quadrilateral that its four vertices A, B, C, and D lie on one circle. At any cyclic quadrilateral, you can find that each two opposite angles are supplementary. Who can remember what the meaning of supplementary? Supplementary means their sum of measures, huh? Yeah, excellent. Their sum of measures equal to 180 degree. So such of these angles are called supplementary angles. So if you find that measure of angle A plus measure of the opposite angle C equals 180 degree, that means this is a cyclic quadrilateral and it must be there a circle passing through its four vertices. And also directly the other two angles, their sum is going to be also 180 degrees, because you know that the sum of the measures of the interior angles of any quadrilateral must be 360. So if there are two angles, their sum together 180, then by subtracting 180 from 360, you will find that the remainder is also 180, which is the sum of the other two angles. Okay, now we can deduce from this that if there are two opposite angles at any quadrilateral, their sum together 180 or supplementary, that means this quadrilateral must be a cyclic quadrilateral, or must be there a circle passing through its four vertices. And let's discuss together why if the sum of each two opposite angles are 180 degrees, then it must be a cyclic quadrilateral. Okay, from theorems that we studied about circle, you know that angle A here is called an inscribed angle. And the measure of any inscribed angle equals half of the measure of the opposite arc, this arc in blue. So measure angle A equals half the measure of this blue arc. And also angle C is called an inscribed angle. So this angle also, its measure must be half of the opposite arc, which is this red one. So if we add measure of angle A plus measure of angle C, it will be half the blue plus half the red. You know that the blue arc and the red arc and the blue arc together form one complete circle, which is 360 degrees. So it's a half of 360 degrees, which is 180 degrees. So when we can find an inscribed angle, of course, in a circle, that means vertex A and vertex C lie on a certain circle. And the same or similarly, we can prove that B and D also must be 180 degrees. The other property for the cyclic quadrilateral that if you find the measure of the exterior angle for a cyclic quadrilateral equals in measure to the opposite of its adjacent. That means this is a cyclic quadrilateral. Okay, so you notice here this blue quadrilateral. Forget this circle in yellow. Forget it. Consider we have only a cyclic quadrilateral A, B, C, and D. And here there is an exterior angle that we named it alpha. You know that any exterior angle and its adjacent one, let's say it's theta. So alpha plus theta are two angles lying on one straight line, or they are supplementary. So their sum of measures together must be 180 degrees. Okay. And also you know that theta plus beta, okay, also equals 180 degrees because of theta is an inscribed angle and its measure equals half of the arc ABD. And beta is another inscribed angle and its measure is half of the opposite arc, which is BCD. So B, beta, and theta together, their sum equal half of the circle, which is 180. And now, so because of alpha plus theta equals 180, and also beta plus theta equals 180, so we can deduce that alpha equals to beta. As an example, if theta is let's say 70 degree. Theta is 70 degree. That means alpha must be 110 because of 110 plus 70 equal 180. Theta never be changed. Okay, it is the same angle, theta, okay, that we used in both cases. And now what plus 70 equal 180? Also 110 degree. That means if alpha plus theta equal 180 and also beta plus theta equal 180, that means alpha must be equal to beta. So that's what we want to illustrate here, that if there is an exterior angle for a quadrilateral, we didn't say it's a cyclic up to now. If you find an exterior angle, its midder, let's say 70, and this exterior angle equals the opposite of its adjacent. The opposite of its adjacent. Where is the adjacent of alpha? This one, theta. Forget it. Where is the opposite? Beta. If alpha equal to beta, that means this quadrilateral must be cyclic quadrilateral. So if there is an exterior angle equal to the opposite of its adjacent, this quadrilateral must be a cyclic quadrilateral. Now let's go to the fourth one of the properties of the cyclic quadrilateral. In the cyclic quadrilateral, each two angles opposite to one base and on one side of it are equal in measure. At any quadrilateral, you can find something that, let's say, DC, one of the four bases or the four sides of the cyclic quadrilateral. You see this line, BC, or this base of the quadrilateral. So, measure of angle 4 or angle DBC. DBC or angle 4 is an inscribed angle, and you know that the inscribed angle equals half of the measure of the opposite arc, which is the arc DC. So angle 4 equal half measure of the arc DC. Also, angle 2 or angle CAD equals half the measure of the arc DC. Angle 2 equals half measure of the arc DC. Okay, and now because of measure angle 4 half DC and measure angle 2 half DC, that means angle 4 equals a measure to angle 2. Angle 4 equal to angle 2. So if you find such these angles D, B, C and C, A, D, two angles like 4 and 2, opposite to one base, which is the base DC, and on one side of it. I mean that both angles must be above the base or below. Not like this. We can draw one base of the quadrilateral and draw angle up and another angle down. No, I don't mean that. I mean both angles must be above the line, or both angles must be below the line, not in different ways of the base. They must be at the same way or the same side of the base. Okay? Okay. So by this way, we can prove that ABCD is a cyclic quadrilateral if you find that mirror angle 2 50 degrees as an example, and mirror angle 4 is also 50 degree. They are opposite to one base, which is DC, and they are on the same side of this base, both of the two angles above the line. That means there is a certain arc here, and they are both equals half the measure of this arc. And of course, if there is an arc, it means there is a circle passing through the vertices of this quadrilateral. Okay, and now let's try to solve some exercises on the cyclic quadrilateral. Okay, in exercise 1, in the figure opposite, EB and EC are two tangents, and we said that one of the corollaries of the circle that the two tangent segments are always equal in measure. Okay, BE and EC are called tangent segments, and they are always equal in measure. From any point outside the circle, if you draw two tangents, the distance from this point to the point of tangency, like EB or EC, it will be the same distance. So that means triangle BEC is an isosceles triangle. Okay? Okay. Now he says FBC equals 3 root 2. 3 root 2. From the properties of the isosceles triangle, you know that the two base angles at any isosceles triangle are equal in measure. So if one of the base angles is 45 degrees, then the other one is also 45 degrees. Okay, and now that means 45 plus 45 equals 90. That means the third angle here must be 90 degrees. And now we have a right angle triangle. From trigonometry, do you remember trigonometry? Yeah, we used to use the sine or cosine or tan or tangent of the acute angle that found in a right angle triangle to solve some problems. So we can use sine or cosine of the angle 45. You know that sine 45 equals 1 over root 2. And also cosine 45 equals 1 over root 2. So sine this angle, what the meaning of the sine of the angle? Sine of the angle is the ratio between the opposite to this angle, like BE, which is opposite to this 45, to the hypotenuse, which is the BC, or the opposite to the angle of measure 90. Sine 45, which is BE, over BC, must be equal 1 over root 2. You know that BE is the same as CE, and the required in the question is to find the length of CE. So if we find BE or CE, both of them are the same length. That means BE over BC, which is 3 root 2, it's given here in the problem, equals 1 over root 2. Okay, so to find BE, we multiply, cross multiplication, scissors. So BE equals 3 root 2 times 1, which is 3 root 2, over root 2, or square root of 2, by omitting square root of 2 with a square root of 2, it will be BE equals 3 centimeter. So the correct answer here is 3 centimeter. Let's find the next question. Okay. Next question is the same as the previous one, but the required here is to find measure angle ABE. ABE, this angle. From the previous example, we say that this angle here inside the triangle, which is angle EBC, is 45 degrees because of this is an isosceles triangle, because of the two tangent segment BE and EC are always equal in length. And now let's find measure angle ABC. From the properties of the cyclic quadrilateral, who can tell me what could be the measure of the angle ABC? Want a clever student that can find the measure of ABC? Yeah, take your time and think about that. ABC and ADC are supplementary angles. because of they are two opposite angles at one quadrilateral. But who told you that ABCD is a cyclic quadrilateral? So clear because of A and B and C and D, the four vertices of the quadrilateral lie on the same circle, which is circle M. So by using the properties of the cyclic quadrilateral, we can find the measure of this angle in green, which is ABC. Measure ABC angle equals 180 minus 68. Okay, let's subtract 7, 10. 10 minus 8 is 2. 7 minus 6 is 1. And 1 in 100. It must be 112 degree. So this angle 112 degree. Okay? Okay. Now the required was angle ABE together, which is the sum of the two angles 112 and 45. Then measure ABE. The required angle is 112 plus 45. Let's add 5 plus 2, 7. 4 plus 1 is 5. And 1 in 100. That means it's 157 degrees. Then choice C is the correct choice. Okay, let's go to the next question. In exercise 3, we have here a figure which is a triangle XYZ, and it is an isosceles triangle. Isosceles triangle, and here, as shown, angle Z equal to angle Y. That means the two opposite sides to these equal angles are the two legs of the isosceles triangle, which are equal in length. So it must be that XY equal to XZ. And because of XZ is 24 centimeter, that means XY is also 24 centimeter. Okay. What is required? Then the perimeter of the quadrilateral ABXC. The required is to find the perimeter of this quadrilateral shaded in yellow here. You know that to find the perimeter of a shape, that means you have to find all of the sides of the shape and add them together. And now let's find, it's shown here on the figure that XB equal to XZ. Here is the sign of the equality. That means this side is 12, which is XB, 12 centimeter, and the other half BZ is also 12 centimeter. In the opposite side, XY, the same. XC equal to XY. You see the sign of inequality here. That means this is also 12 centimeter and this is also 12 centimeter. So go back to theorems that we studied in Prep 2 in the second stage of preparatory stage, or the second year of the preparatory stage. We said before that FB is the midpoint of one side in a triangle, which is the triangle XAZ. That means AB is a median. Do you remember median? Median goes from any vertex in the triangle to the midpoint of the opposite side. And it was their special case. In the right angle triangle especially, the median drawn from the vertex of the right angle to the midpoint of the opposite side, this blue line is called median. And this median in the right angle triangle, especially this median drawn from the vertex of the right angle, its length halves the length of the hypotenuse. So we have remembered together this previous theorem from second prep that the median drawn from the vertex of the right angle in the right angle triangle, its length equal half the length of the hypotenuse. So the length of AB median half the length of the hypotenuse xz. And you know that this hypotenuse is equal to 24 centimeter. That means AB is also 12 centimeter, which is half of 24. Similarly, on the left hand side, AC drawn from a right angle to the midpoint of the opposite side, it is a median and its length half the length of the hypotenuse, which is also 24, and that means this side AC is 12 centimeter tall. Now, in the quadrilateral XBAC, the four sides are equal in length and each one of them equals 12 centimeter. Then 12 times 4, 12 plus 12 plus 12 plus 12 equals 48 centimeter, which is the perimeter of the quadrilateral. Then the correct answer is 48. Let's see the next question. Okay, an exercise 4, it's one of the exercises on algebra and third prep. It is called about ratio and proportion. It's talking about ratio and the proportion. If x over 3 equals to y over 4 equals to z over 6. We said before that any number of equal ratios to each other called something which is a proportion form, or it is one of the forms of proportion. And it must be there a certain value, which is, let's say, m, or any letter, any expression, okay? X over 3 equal y over 4 equal z over 6. It must be equal a certain value, which is m. As an example, if I say that 6 over 3 equals 4 over 2 equals 8 over 4, all of them at last equal 2. 6 divided 3 equal 2, 4 divided 2 equal 2, 8 divided 4 equal 2. So if there is a proportion form that consists of different ratios and all of them equal to each other, it must be there an end result which is equal to all of them. So we can say that z equal 6m and y equal 4m and x equal 3m. X equal 3m and y equals 4m and z equals 6m. And now let's substitute here in the problem. 2x means 2 times 3m, which is 6m, plus y, which is 4m, and instead of y, 4m, minus 2z, just one z equals 6m, then 2z, 12m. Down in denominator, 2y, which is 8m, 2y, 8m, minus x, which is 3m. And now all of them become of the same variable m. We can add or subtract them from each other. 6m plus 4m is 10, 10m. 6 plus 4, 10. 10 minus 12 is negative 2m. Down 8m minus 3m. 8 minus 3 is 5m. By omitting m and m because of any symbol or any number divided by itself equal 1, that means the end result is going to be negative 2 over 5. Negative 2 over 5, which is the choice C. Okay? Okay. Let's see the next question. Okay. Here, in the given figure, FO is the origin point of an orthogonal coordinate plane, and the slope of BC, this red straight line, You know that any straight line has a slope. The slope of BC, the red one, is 1 over root 3. 1 over square root of 3. And the equation of the other straight line AC in red and blue here, AC, its equation is x minus 9, x minus y equals 9. Okay, so what is the required? The required is to find the measure angle ACB. ACB. This included angle here, we want to find its measure. Okay, we are going to depend on the concept of the slope here in Prep 3 or the third year of preparatory stage. But in secondary stage, we are going to know a new rule that directly find the measure of the angle included between two straight lines. Okay, now how we can use the concept of slope to find out the measure of this angle. Okay, you know that the slope of any straight line equals tan of the angle of an inclination. Of course, you remember the angle of an inclination, and let's remember it together. The angle of an inclination is the angle that the straight line formed with the positive direction of x-axis. Okay, so for the first straight line in red, which is BC, we have an angle of an inclination, and the tan of angle CBA equals the slope of the straight line BC. The slope of the straight line BC is 1 over root 3. And when you know one of the trigonometric functions of any angle, you can easily find the measure of this angle using calculator. Just write on calculator, shift 10 and write 1 over root 3, then press equal, it will be 30 degree. So using calculator, we can deduce that this angle of an inclination that the straight line BC makes with the positive direction of x-axis equals a measure 30 degree. Okay, by the same way, we can find the measure that the straight line AC makes with the positive direction of x-axis using the slope of the other straight line AC. But the slope of the other straight line BC is not given in the question. And instead of that, we have the equation of the straight line. You know from algebra that we can find the slope of any straight line given the equation of this straight line from negative coefficient of x over coefficient of y, which is negative 1 over 1. Negative 1, negative coefficient of x, over the coefficient of y, which is also negative 1. Negative 1 over negative 1 equals 1. So the tan slope is the same as the tan. Slope of the straight line is the tan or the tangent of angle of an inclination that the straight line AC makes with the positive direction of x-axis. So we can find now the measure of this angle, the angle of an inclination. Tan this angle equals 1. Tan of the angle CA, let's say D here, CAD equals 1. That means this angle is 45 degree. The acute angle whose tan equals 1 is the angle 45 degree. You can find that easily using your calculator. And from the measure of this angle 45, you can easily find the supplementary one inside the triangle, the supplementary one. Okay, using 180 minus 45, it is going to be 135 degrees. So forget this because of we want to find the angle inside the triangle, not the angle of an inclination that lies outside the triangle. We don't need this one. We need this one in green, which is 135. Now in triangle ABC, you have two angles are given, 135 plus 30 degree. It will be together 165 degree. And you know that the sum of measures of the interior angles of any triangle must be 180. That means the third angle here, which is angle BCA, equals 180 minus 165 degree. It will be at last 15 degree, which is the choice B. Now let's see the next question. Okay, it's an easy one. The rational number a over b is positive. That refers to the first year of prep school. We studied it before. The definition of the rational number, it is the number that can be written in the form a over b such that b does not equal 0, and also a and b are both integers or integers numbers. Okay, so when we can say that the rational number a over b is positive. Okay, when we can get a positive number by dividing negative by negative number, it will get as a positive number. And when dividing a positive number by positive number, we can also get a positive number when dividing numbers with the same sign. That means A and B must be negative together or positive together. So when multiply a negative number by another negative number, negative times negative, it will be positive, which is bigger than 0. And also, if both A and B are positive numbers, when multiplying a positive number by another positive number, also you will get a positive number and it is also bigger than 0. That means A times B, even they are both negative or both positive, their product or the result of their multiplying is going to be always positive value. So I can guess that I should take the last choice D, that A multiplied B must be bigger than 0. Next question. Yeah, this quadratic function, okay, we studied in algebra the quadratic function, and we said that in any curve, there is a straight line that divided this curve into two equal halves or two congruent parts. This straight line that divides the curve into two equal halves passing through a certain point here on x-axis. And the coordinate of this point, let's say C, the coordinate of point C must be a value or a certain value on x and 0 because of this point lies on x-axis. So let's find what is the value of this x by putting y equals 0 in the function. F of x equals negative x squared plus 4x plus k minus 2. Put y equals 0. Okay? Okay, so x and 0 is this point that lies on x-axis. Okay, where is the y here? The y is here outside. Okay, and also A and B are 2 points satisfied. Okay, so we have here another given that OB the distance from O to B is 3 times the distance from O to A, or the ratio between them is 3 to 1. Okay? Okay. Now, you know that this point is called the vertex point of the curve. And we have a rule to find the vertex point of the curve. The vertex point of the curve is negative b over 2a and f of negative b over 2a. So we can find easily the vertex point of the curve. And the straight line or the axis of symmetry of this curve passing through the vertex point, which have the same x coordinate of point C. So this is another way and an easy way to find the x coordinate of point C instead of substituting here in the equation. Okay, so let's move in this way using the vertex point of the curve. Okay, so the x coordinate equals negative b over 2a. And from the equation here, or from the function here, negative b is negative 4 over 2a. A is the coefficient of x squared, and here it's negative 1. 2a, 2 times negative 1, which is negative 2. Negative divided negative is positive, 4 divided 2 is 2. So x here lies at 2. And the point C here is 2 and 0. Instead of x here, put 2. 2 and 0. So point C, point C far from the origin point by 2 steps. Okay, so he says here that OB equals 3 OA, or the distance from O to B equals 3 times as the distance from O to A. Okay, so we can move using this idea, okay, that this distance 3, okay, and this axis of symmetry in the middle exactly. So OB are 3 equal parts. OB 3 equal parts. 1, 2, 3. And OA just one part. So the line that divides this here passing at 2. That means here is 3, here is 4. Okay, no, they are equal distances. I'm sorry. Okay, so because of the first distance is 2 steps, 2, and another 2 is going to be 4. Okay, and here is 0, 2, then 4. Yeah, and here a is negative 2. Okay, so here point A at negative 2 and 0, and here point B at 4 and 0, and the middle is 2. Okay? Okay, so now we want to find the value of K. Using any point like B and A, let's substitute. Yeah, here 2, negative 2, 2, 4 steps. So on the other hand, it must be 4 steps. So 2 plus 2 is 4. 4 in the middle. So it must be 4 steps. That means this is going to be 6, not 4. 4 to the left of the axis of symmetry and 4 to the right of the axis of symmetry. That's okay. So using this point, negative 2, we can substitute to find the value of k. Okay, -2 and 0, verify. Okay, instead of x, put -2, so it's -2 power 2 plus 4 multiply -2 plus k minus 2 equals 0. -2 power 2 is 4 وهنا في negative outside plus 4 times -2 which is -8 plus k minus 2 equals 0. -4 and -8 are together -12 plus k minus 2 equals 0. -12 and -2 are together -14 plus k equals 0. Get this 14 to the other side with with different sign or opposite sign. That means k is going to be 14. Okay, also if we used the second point, which is 6 and 0, it will also satisfy the question and get the same answer. Next question. Okay, it's the same as the previous one, and the required is the point of intersection of x-axis, okay, where OB equals 3OA. What is the equation of the line of symmetry? We said before in the previous example that the straight line which divided the curve into two congruent parts or two equal halves, it is called the axis of symmetry. It passes through the vertex point and the certain point C, which is 2 and 0 on x-axis. So this straight line passes by a certain value on x, which is 2. That means its equation is going to be x equal 2, and this is a constant relation, okay, because of all of the points on this straight line whose x coordinates is going to be 2, 2 and 0, 2 and 1, 2 and 2, 2 and 3, 2 and any other value. So the equation of the straight line is going to be x equal 2. Now in exercise 9, the same as the previous example, and the required here is to find the point of the vertex, and we said that this vertex point, its x coordinate, the same as the x here of point C, which was 2 and 0. So it's 2 and another value. We want to find this value. Or from the rule of the vertex point that y coordinate of the vertex point of the curve of any quadratic function can be found out of f of negative b over 2a, which is f of 2. By substituting in the equation and replacing any x with 2, f of x here, or f of x here, yeah, in the equation is negative x squared plus 4x. Okay, and we found before that k, or the value of k was 14. So 14 minus 2 plus 14 minus 2, then it's negative x squared plus 4x plus 12. Now let's find f of 2 by replacing each x with 2. So it's negative 2 to the power 2 plus 4 multiplied 2 plus 12. It will be negative 4, 4 times 2 equals 8 plus 12. 12 and 8 together are 20, or let's move in order using the rules of the order of mathematical operation that we have to subtract first, then add. Okay, we're moving from left to right. Negative 4 plus 8 is going to be 4, plus 12 is going to be 16. So this point is 2 and 16, which is the choice B. In exercise 10, this relation from x to y, where r represents a function and the relation between a and b means that a must be a factor of b. So a is any element belong to the set x and b is any element belong to set y because of this relation from x to y. We take the first projection from the first set and the second projection from the second set. You notice here that both sets together, the union of x and y, 3, 4, 5, 7, 8, 13, 25, 49. And the number of elements n of x equal 3. Number of elements of the set x must be 3 elements. And the number of ordered pairs in the Cartesian product x times y is 12 ordered pairs. That means set of y must contain 4 values because of 3 values times 4 values equals 12 ordered pairs in the Cartesian product. So to be x a factor of y, that means x must be contain a small number like 4, 5, and 7, and the other values 8, 13, 25, and 49, and the other set y. Now 4 is a factor of 8, 5 is a factor of 25, 7 is a factor of 49. Okay, so 4 can be contact with 8, 5 is a factor of 25, 7 is a factor of 49. The required is to find the relation R, so it's 4 and 8, 5 and 25, 7 and 49, which is the choice letter D. 4, 8. 4 is a factor of 8, 5 is a factor of 25, 7 is a factor of 49. Okay, so let's see the next question. Okay, it is the same question, okay, and the required is to find the range. And the previous one, on the previous question, we said that x contains 4, 5, and 7. Set of y contains the other elements 8, 13, 25, 49. And from the concept of the range is the second coordinates of all ordered pairs, or for getting out from 8 an arrow going to 8, 5 contact with 25, and 7 contact with 49. So these second coordinates of each ordered pair and the relation are called the range of the relation. Okay, so the range here are the relation from x to y, which r represents function. Okay, r here represents function. You know that if the relation does not represent function, it will not be there at range. But because of each element here in x getting out from it one and only one arrow to an element in y, that means 8, 25, and 49, the range of this function. 8, 25, and 49, yeah, this is choice letter D. The last question. In the last question, in the figure, that requires to find the measure angle MXL. MXL. This angle. Okay. Now, let's see. We have here a triangle in yellow, and we have another triangle in blue. If you notice carefully, you are going to find that these two triangles are congruent because of side, angle included, and another side, side, angle included, and another side. Side ZM equals XY. ZM equals XY. And measure angle Y, which is included, equal to measure angle Z. Angle Y congruent or equal to angle Z. Also, YM equal LZ. YM equal LZ. So now we have angle, side, angle. One of the cases of congruency of two triangles. That means triangle XYM is congruent to triangle. We started with X So we have to start with M and then the right angle, and then the last one here, M, is congruent to the last one here, L. So now, because of these two triangles, the yellow and the blue one are congruent. That means the third side here, or the hypotenuse of the first right angle triangle, is equal to the hypotenuse of the third side here. So we can deduce that LM equals XM. So the triangle XML, in which we have two legs or two sides equal in length, must be an isosceles. An isosceles triangle have two angles equal in measure, which are the two base angles. One of the two base angles is the required to be found. Okay, now how we can find these two angles which are equal in measure and we don't know this angle? Okay, if you guess, you will find that this angle is 90 degrees, but we don't use to guess in mathematics. Everything has to be proved. Okay, so you know that the three angles here on a straight line must be equal 180 degrees. Okay, so this angle with this one together 90 degree, because of we have here y 90 degree. That means the circle and the cross together 90 degree. Also this cross that's equal to this one and this dot that's equal to this one together 90 degree. So a dot or and the cross together 90 degree, that means the third angle in the middle of them or in between them must be 90 degree. So angle LMZ plus measure angle XMY equals together 90 degree. Then measure XML equals 90 degree. So because of this angle in the middle is 90 degree and this is a right angle triangle and isosceles at the same time, that means the two base angles each of measure 45 and the other one is 45 because of 45 and 45 90 and the 90 here, so they are all together 180. That means the required angle must be 45 degree and this is the correct answer. Finally, I wish you can understand cyclic quadrilateral very well and also the revision exercises that we do together now. Uh, okay, wish I can see you later. Thank you and goodbye.